Alrighty, good morning. Welcome to lesson 2.2, and we'll be talking about circles. Now, since we're talking about circles, we're going to start off with some vocabulary that is specific to circles. The first one is diameter. And what diameter is the distance across a circle. Alright, so when I say the distance across a circle, I am talking about this guy right here, that blue line. Alright, all the way across a circle through the center. Whereas the radius is the distance halfway across the circle. Right? Halfway, which is this red line here. If you ever get mixed up between diameter and radius is a shorter word, so it should be the shorter distance. And lastly, circumference. Circumference is the distance around a circle. So that is this green part, the circle itself, the distance all the way around. Now remember, we had a special word for the distance around a shape. That is the perimeter. So the circumference is also the perimeter of a circle. Okay, same definition, same thing. So, or same thing. All right. So this activity here, if you want me to explain it, you can do it in class. That is fine. Just flag me down and let me know. But whenever we talk about circles, we want to talk about pi, and pi is actually what that activity is about. So if you have a circle, and you take the distance around the outside, the circumference, take that distance, and you divide it by the distance across the circle, you will get the same number for every single circle that you do. That is called pi. That is this number here. So you could write it like that, or you can call it pi. Sometimes you'll see me write it like a hat, like this. It's all the same thing. And it is a number that is 3.1415 something 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 something. And this number goes on and on and on and on forever. So instead of writing this number that goes on and on and on and on forever, that's why we use these symbols. All right, it's way easier to write one thing than a cajillion things. Now, when a number goes on forever, we have a special name for it. So pi is an irrational number. Right, irrational. I'm good at spelling. Pi is an irrational number. What that means is you cannot write it as a fraction. It goes on forever as a decimal. It is a never-ending decimal. Okay? A never-ending decimal. And that's what an irrational number means. Ready? So, what is pi? What's so important about it? We mentioned a couple things. One, it is circumference divided by diameter for any circle. Okay? We will use it as a tool when working with circles. Because it only works for circles, it becomes a very, very useful tool. So, building off of this circumference divided by diameter, you could write this as the fraction. Same thing. Or a ratio. Or my favorite way to think about this is the number of diameters in the circumference. Sorry about my penmanship here. In the circumference. So what that means is, if I had a circle, and it has a diameter, if I was to unroll this circle, or if this was a string and I was to straighten it out, it would be the same as having 1, 2, 3, and a little bit. You would be able to get 3.14159 diameters out of that circumference if you unrolled it. So just over 3, which is kind of cool. It's a nice visual way to see pi. Now, another visual is this one here. That is what one slide full of pi digits look like. And this is why we do not use the number. Okay? Now remember, pi is just this number, and we are using a little symbol for it. If you have to type in the number, or if you're using a calculator that does not have a pi button, just use 3.14. That'll work good for our sake. So, I also said pi is a tool. So we can use this tool to make us some formulas. So, in the previous slides, I said pi was equal to circumference divided by diameter. That's what pi is. Now, if we wanted to get circumference by itself in this formula, well, I'm dividing by diameter. If I want to get circumference by itself, I'm going to multiply by diameter. But I'm going to do that to both sides. All right, now I've got a diameter on the top, diameter on the bottom. Those cancel out. And now all I'm going to have left with is circumference on this side and pi times diameter on the other side. I don't know why it's erasing for no reason. Pi times the diameter. Right, so that gets you circumference by itself. Now what if you don't know the diameter? Now remember, we said the diameter is the full way across the circle. The radius is the halfway. So diameter is the same thing as 2 halfways across the circle, or 2 radiuses, radii. So if the circumference is equal to pi times the diameter, well, diameter is the same thing as 2 radiuses. So I can rewrite that as pi times 2 radiuses. And then we would just rewrite that because that's not a very pretty way to write it. So when we're writing stuff, we usually like to have the numbers up front. So 2 times pi times the radius. That's another formula for a circumference. So just using pi, we've come up with 2 different tools for finding circumference. Ready? So we might as well use these. Okay, let's look at an example here. So, in our example, the Temple of Hercules, near Rome, was built in the 2nd century. This temple has a diameter of 14.8 meters. Calculate its circumference. So that's the temple right there, and as you can see that it is a circle. So the base of it is a circle, and I know that the diameter, which is the distance across, is 14.8 meters. And I'm looking for the circumference. Alright, so I know the diameter, and I know the formula for circumference using diameter is just pi times the diameter. Right? So C, or circumference, equals pi times my diameter, which was 14.8. I can plug that into my calculator. So here's my pi button somewhere. There it is. Times 14.8. And that gives me a really long decimal. Right? Now in my question it says I just want it to the nearest tenth, so I'm going to round to 1 decimal spot. So what was that number? It was 46.49. I'm going to the tenth, so I'm going to round that up to 46.5. So C equals 46.5 meters. And that is it. Easy peasy. Let's do another example. The radius of a bicycle wheel is 14 inches. And that's the radius. Calculate how far the wheel travels when it turns one rotation. That's the same thing. When a wheel travels one full rotation, so this is my wheel. Once it travels a full rotation, it's the same thing as if you were traveling around the circle. Okay, so that's the circumference is what we're looking for. And you probably could have guessed that because we've been talking about circumference for this entire video. So we're looking for circumference. Now, because I know the radius, I'm going to use the other formula. The one that uses radius. It's 2 times pi times r. So, 2 times pi, and my radius was 14. I can just punch that straight into my calculator. 2 times pi times my radius, which was 14. Bam, there we go. 87.96 inches. That doesn't say where to round it, so I'm just going to round it to the nearest inch. So I'm going to say 88 inches. And that's it. Cool, cool. Now, what if you know the circumference and you're looking for the diameter? What if you're going the other way? So, one thing you can do is you can manipulate the formula. So that means doing math without any numbers. So you start with the formula. And right now, it has c by itself. That's what it's set up to find. Now, if you want to get diameter by itself, you need to undo this multiplication. So to undo that multiplication, you have to divide by whatever it is you want to get rid of. You want to get rid of the pi, so you got to divide by pi. Now, but whatever you do to one side, you got to do to the other. Now I've got a pi up top, a pi on the bottom. Pi divided by pi is just 1. So they can cancel out or cross off, whatever you want to call it. So now I just have diameter by itself equals c divided by pi. Now this formula you won't find on your formula sheet. If you want this formula, you have to manipulate it by yourself or have it memorized. Alright, let's do one last example. When a golf ball rolls on the green, it moves a distance of 13.5 centimeters in one rotation. So remember we said one spin is the same thing as circumference. I want to know the diameter of the ball, and I don't care what fits in millimeters. I just want to know the diameter. We'll change it to millimeters if you want. It's up to you. Alright, so I can do this 2 ways. First way is to use that handy dandy formula we just made, where I know that diameter equals circumference divided by pi. My diameter equals my circumference was 13.5, and pi is just pi. And I can go straight to my calculator now. 13.5 divided by the number pi, 4 it's set to the nearest tenth, so 4.3 centimeters. Pretty good. Now, what if you forgot that formula? Oh no, I can't remember the formula for diameter. I have to do something different. Fear not. This formula is on your formula sheet. You don't need to remember it. C equals pi times d. So now, what you're going to do is you're going to take the number from your question and you're going to put it in the formula. But make sure you put it in the right spot. This is circumference, so it has to go where the c is. So 13.5 equals pi times d. Now diameter is what you're looking for. You got to get that by itself. So you need to undo that multiplication. Remember, that is multiplied by pi. So that's pi times d. So you need to undo that multiplication. Opposite of multiplication is division. But whatever you do to one side, you got to do to the other. Got a pi up top, pi on the bottom. Pi divided by pi is just 1, so they cross off. So now I have diameter on one side and 13.5 divided by pi on the other. Hey, look at that. Different ways came to the same thing. So I bet you they'll come to the same answer. You don't believe me? Check on your calculator. 13.5 divided by pi. Exact same thing we did last time. We're going to get the same answer. 4.3 centimeters. Alright, D equals 4.3 centimeters. Awesome. Alright, now check out these practice questions. Make sure to check your answers. They're all working with circles and pi. Alrighty, good luck. And like I said, ask me if you have